Hi, good morning, guys. Here again, should be Wednesday as you're watching this. Same thing as Monday. You're gonna do the same assignment or same type. You're gonna do this the same way. Watch the YouTube video, log on Zoom, do your assignment, be done with it. It won't take you long. 8-9 questions is all it's gonna be today when we talk about atomic structure and isotopes. So a little bit of a PowerPoint to go along with it. Basic atomic structure and mass. So if we look at this, just remember the other day we talked about the electron as a negative charge by J.J. Thomson. He's the one who found it with cathode ray tube. The proton has a positive charge. Remember, it was Rutherford with the Goldfull experiment, and then we had the neutron. Mass number of the electron 0 because they're very small. Proton and neutron are both 1. The location of the electron in the electron cloud, we're fixing to look at that, and we know the proton is inside the nucleus. So here, this is what we see when you watch Big Bang, when that show comes on TV, okay? This is what you see, and these things are zooming around, and this is what we give these their orbitals. This is technically what an electron is. In the center, that little small black dot there is where your proton's at. The outside ring, that darker part, is where the electron is. Those guys are moving so fast that we really don't know where they're at. So that technically here is the electron cloud. They're not in set orbitals. We're going to talk about orbital levels and where they should be, and that goes into Heisenberg's uncertainty principle. Like we can maybe know where they're at, but we don't know how fast they're going. Or we can see how fast they're going, but we don't know maybe where they are. So this is technically what it looks like when you look at an electron under an electron microscope. What holds these things together? So you think about the nucleus, okay? So you got the proton here and the neutron. So those are all positive charges. We know positives repel one another. As those positives repel one another, what's going to hold it together? So we talk about the nuclear forces. It's called the residual strong nuclear force. The residual strong nuclear force is this proton here is being pulled in one direction and pushed in one direction versus the other one, because these protons are very close together. Here the neutrons are helping keep these guys together and not let them fly apart and let the atom just implode on itself. Atomic radii. This is another big part of atomic structure. With atomic radii, basically, radii, you know, from the center to the outside is the radius. So the further we go down that periodic table, the bigger the radius is going to get. Technically, everything in group 1 at the bottom, which is francium, francium has the largest atomic radius on the entire periodic table. And those things get further apart because you've got the protons in the middle, the electrons on the outside. The further that positive charge and the negative charge get further away from one another, it just keeps spreading out. So to begin with, it's really tight. Hydrogen plus 1, you know, it's got 1 proton, 1 electron, 1 neutron. That positive, that negative are really close. Because think of it like a magnet being stuck really close together. But if I take those electrons and I keep moving them further and further away, our radius gets larger and larger and larger. So as you add more electrons, and you have fewer protons, we'll talk about valence electrons a little bit later, you're going to see that that residual force is not going to be strong. So the radius gets larger and larger. Coulomb, we'll talk about Coulomb's laws. Coulomb's forces, the closer the electron, the stronger the force. Again, I basically just said that right here. So of these 3, this guy would have the strongest force on him. These 2 would have the least amount of force on him because he's closer to the protons. So that's what Coulomb's law is going to be. Closer a positive and negative, the stronger the attraction. The further apart the positive and negative, the less the attraction. That's Coulomb's law. We know how to find the atomic number. Finding atomic number of an element is the number of protons in the nucleus of each atom. So, to find the atomic number, when we look at the periodic table, you guys are not here, but when we look at it, the top number is always the atomic number. You learned that in Miss Manger's class when you were in the 8th grade. The bottom number is going to be the atomic mass. The atomic number is going to tell you the number of protons that are in that element. So, carbon is number of protons is 6, its atomic number is 6. Phosphorus, number of protons 15, atomic number 15. 79, 79, you get the hint. All right, you get it right there. That's very simple, very easy to understand. The mass number, though, is the number of protons and neutrons in the nucleus of an isotope. You remember, we did not say anything about electrons because they don't have a mass. They're super, super small. So, when we look at this, if we look at oxygen, and I'm just going to fill in the first one, and then we can kind of do the second one together. So the first one, its atomic number is going to be 8 because it had 8 protons. It had 8 protons. Right now it's got 8 electrons. Can that change? Yes, but we'll talk about that a little bit later down the road. It has 8 protons, 10 neutrons. We add the 8 and the 10 together. That gives us the mass number of 18. Okay, so that is an isotope of oxygen, which is oxygen 18. The next one, we could go find and see what phosphorus is number, we could go look at what proton is number 33. So if we use and we see a periodic table, number 33, when we look at this, is going to end up being arsenic. I can go straight to it on my periodic table. 33 is arsenic because it has this. So that tells me the number of electrons are also going to be 33. To find my mass number, all I have to do is add up 42 and 33, which we know is going to be 75, okay? So this becomes 75, this guy's 33. Arsenic here, the nuclide, its mass number, arsenic, when you look at this, should be 75. The next one, we go find what number 15 is, so we can find the name. 15 is going to be phosphorus, so it's going to be phosphorus 31. Now we know it's 31, we can do the rest of it. 31 minus 15 is going to be 16. That's going to be our neutron. The electrons are going to be, again, 15, same number of protons. So if we fill it in, we know it's 31, we know it's phosphorus, 15, and 16. So that's the way this is going to look. If at any point you need to pause this and look at it again, that's fine, or back it up, okay? So this is what we've got for mass numbers. Really simple, you've done this before. The periodic table is based off of atomic masses. This is Dmitry Mendeleev. Mendeleev gave us our first periodic table, which is in 1869, which is pretty phenomenal that he realizes this. And when you look at Dmitry's first periodic table, this is kind of the way he put it in order. He put it in order by atomic mass. So we start with hydrogen, 1, beryllium, 9, boron, 11, carbon, 12, nitrogen, 14. Those are still true today. He had them exactly, had them perfect for what they should be. He knew exactly what their masses were. Now we added to this, and there's a few that are a little bit off, but not many. Very, very smart man that gave us this. So remember, periodic table is based off of the atomic number, and it goes in order by atomic mass. Here's our modern periodic table. We'll have one of these, we'll make one of these, and you guys will have a project that goes along with this that we'll work on in class. Just remember, I kind of already said that for you, the atomic number is always going to be here, all right? It's always going to be the top number on the periodic table. Atomic mass will always be the bottom number. Atomic number on top, atomic mass on bottom. So atomic mass, I've got 6 protons, 6 neutrons of carbon. I add those together. It's going to give me my atomic mass of 12, which we saw a while ago. We talk about notations, isotope and hyphen notations. This right here, when we look at this one, is going to be our isotope notation. So when we talk about isotopes, all these different elements have different numbers of neutrons. That's what separates them and makes them a little bit different. We've got carbon, carbon 13, or this is carbon 12, carbon 13, carbon 14. I know it's carbon 12 because 6 plus 6 is 12. I know this is carbon 13, 6 plus 7, 6 plus 8, 14. Now, what's the difference between them? Carbon 12 is what we see naturally occurring on Earth. Carbon 14 is what we carbon date things with. We can date things that have carbon in it up to 10,000 years old. Anything after that has to be radioactive dating. But that's one way that we use these. But why are they different? Again, just look at their number of neutrons. Hyphen notation. Sorry, let me go back. This is isotope and hyphen notation, the way it's written. This way is written as nuclear notation, okay? So with this one, we know we got 3 neutrons, 3 protons. We add those together, that's going to equal 6. So the atomic mass is on top. 6 is on top, the atomic number is on bottom, which is lithium. Lithium, this is a different isotope of lithium because it has 4 neutrons. So the weight carries a factor. Now, we're going to calculate average atomic mass. I'm going to move the camera here to the board. With this, we So you've got an isotope. So everything has different isotopes, like we said, because they have different numbers of neutrons. If they have different numbers of neutrons, this is how we find what the average atomic mass is going to be. So the isotope, this is an isotope of what we call Mg, which is magnesium. Okay? All right, Mg24, Mg25, Mg26. Remember, that's its atomic mass. This right here, this number for each one of those is the atomic mass of that, of what we naturally find on Earth. These are its percentages, okay? So if these are its percentages, we've got what we need. All we have to do to be able to solve these type of problems, and you'll be able to log on to Zoom if you run across a problem and how to do these. But all we have to do is take the magnesium, which remember, this is its atomic mass. This is the percent of atomic mass that we find naturally occurring on Earth. But we find 10% of it to be magnesium-25, 11% to be magnesium-26. What is its average atomic mass? Take the percentages and change the percentages just to a basic number. If this is already 78.99%, all you have to do, again, this was a percentage, move your decimal point 2 places to the left. So 0.7899. Move it 2 places to the left, 0.1000, 2 places to the left, 0.1101. Now you're going to take this 24 and you're going to multiply it. So I'm just going to rewrite it, because you're going to multiply it by what its mass was to be able to find it. So 0.7899 times 24, let's make sure you can still see. Okay, yeah. I know that light's a little bit in the way, and I'll move that light here in just a second, and I'll kind of zoom in on it so you can see it and you can pause it. 0.7899 times 24. 0.7899 times 24, we get 18.96. We'll take this to the hundreds place. The next one, 0.100 times 25, we know is going to be 2.5. 0.1101 times 26, we know is going to be 2.86. Now, to find the average atomic mass, all I have to do with those three numbers is add those three numbers together. We add those three numbers together, 18.96 plus 2.50 plus 2.86, we get 24.32 grams of magnesium. That is the average atomic mass of magnesium. And the way that it was calculated on your periodic table was just like this. Because now if I go find magnesium on my periodic table, we found it to be 24.32. On our periodic table, it's 24.31. So that's how they find the average atomic mass of each one of these things. That's where the atomic mass number comes from. The atomic mass number comes from the different isotopes of each element. So I'm going to zoom in on this for a second. You're going to log into Zoom now. You're going to complete the problems, and you'll be finished for the week. Also, remember that you have until Sunday to complete these problems.